Okay, so great. So welcome everyone. First of all, thank you, Sandra. Thank you to the Baruch AIS student group for organizing all these events. I think these are very useful for students. So today I'm gonna walk you through the life cycle of like machine learning project, right? And again, we're in a business school, so I'm gonna first start with some conceptual framework that could help us uh, think and frame a business problem as a machine learning problem as understanding the what's the business problem, and then the life cycle of the entire machine learning process, right? Uh, Probably should have reduced this image, but the idea of the CRISP-VM framework is that we first start with the business understanding, and then what's the business question, right? So in this case, as the invite said, one of the common problem in machine learning it's reducing churn, right? So I'm gonna differentiate between like the pure machine learning and mathematical and algorithmic processing of data uh, with applied machine learning, right? Which is using some of these tools, some of these techniques into solving a business problem, right? So today, the business problem is, there's a telecom company that has customer data, and they basically want to learn the behavior of some of these customers that churn, which churn means they leave the company, right? So if you're an AT&T user, someone churning would probably go to the competition, right? Verizon, T-Mobile, right? So if churn, it's definitely not good for the business because if we start losing customers, then we can our bottom line decreases, and we can ultimately get hit from a financial standpoint, right? So and oftentimes what happens is that it's easier to maintain a customer than to acquire a new one, right? So you want to keep that customer lifetime value high, the tenure of that customer high, right? Because it's sort of like easier. So the idea here is that from a business perspective, right, if you're able to learn um, which customers potentially are customers that are going to stop doing business with you, right? You can bring your peers from marketing, looking at creating marketing campaigns, looking at the behavior of those customers, and tailoring some intervention or initiative to prevent them from that outcome from happening, right? And that's the idea, right? We were moving towards a more personalized experience, right? Every product and service you consume, we like to have an experience that we feel it's personal, right? We don't want like marketing ads that are one size fits all type of thing, right? There's customer segmentation behind the ad I'm looking at. It's relevant to me, right? It's a product or type of product that I would be interested um, in looking at, right? So even think about if you're a financial institution, right, which type of products serve well, which age group, right? We're not going to be offering products that are more risky, maybe for someone that it's more closer to retirement, right? So it's all about that personalization based on historical data. Okay, so and again, let's make this is definitely not a lecture, right? So we can make this a little bit more informal. If you want to jump in, feel free to ask any questions if you get lost, right? There's no expectation of prior experience. So if there's something that you don't understand, feel free to ask, because probably there's going to be someone else in the same situation. Okay, So the idea is that when we're talking about machine learning, right, it's this concept of a learning artifact, right, that based on historical data, it's looking at patterns and then it's going to use those patterns to make some sort of prediction, okay? And that's something called supervised machine learning, right? And the reason why we call it supervised, right, is because we have some sort of outcome we're trying to optimize for. In this case, the outcome is whether a customer churned or not, right? This is historical data. Then we're going to use this historical data to make a prediction on current data, meaning we have information about a customer, but we still don't know whether that customer will churn or not, okay? So we're going to use the historical data to find the patterns. And once we abstract those patterns, we're going to use those patterns and look as to whether this customer that it's current, whether it has a risk for potentially churn. Okay, does this make sense? Thumbs up if if this kind of makes sense. If you're following along, I don't know if there's probably a thumbs down also. Let me just see how we're doing, right? Because it's right at the start of the workshop, so I don't want to lose anyone, okay? And again, this is more of a learning experience than it is a lecture. Okay, I did get 4 thumbs up. I don't know if the rest of the folks are getting coffee, but I see more thumbs up, so great, perfect. So we're gonna move on, right? So that's sort of the notion of business understanding when we're talking about trying to frame a business problem into a machine learning problem, right? The next step in the CRISP-VM model, it's this notion of data understanding, right? If we have a problem, right, if we're trying to predict who's going to churn or not, right, then the next thing would be, okay, do we have the data necessary to solve that problem? And a lot of intuition comes behind this, right? Because, okay, you will say, okay, we need, current customers, their demographic information, their payment information, their product subscription information. Let's see which products and services they're consuming, and so on, right? And then you would go to that functional area in the organization and try to get that data, and then through some ETL process or some process of gluing all these data together, then you would come up with a data set, right? So see how the data understanding, it's important to understand, because the first thing is, does it make sense to use this particular data to solve this business problem? Okay, and then the next thing, it's like once you have the data, it's like start preparing the data in a format that it's amenable for machine learning. Okay, then we're going to build some predictive models. We're going to evaluate those models, and if we're happy with those models, then we're going to deploy it into the organization. Okay, and once we deploy it, it's when that systems becomes live and it's looking in real time, maybe, or near real time, assessing and putting risk scores to different customers and seeing, which customers need some sort of human contact or have someone from customer service and reach out to them and say, hey, look, we noticed you sort of stopped using your minutes now, or you're not using your TV anymore, or things like that, as a proxy of saying, hey, look, there's this better product or that could be more applicable to your usage pattern, right? Because you don't want to have customers overpaying, because eventually they'll find out that they're overpaying and someone will entice them to move and use a different product from a different company, okay? But the other thing, if you look this outer loop, right, outside the CRISP-VM framework, it's just saying that, this is an iterative process, right? It's not like we do it once and then we forget about it. We're constantly with new data, with new customer data. We make new changes. Okay, so this actually comes from I teach a graduate course on business analytics and another on data mining. So this was a data set I used for an exam, right? And the idea was that students go through the life cycle of a project and try to find the patterns. So if you look, right, I'm using Jupyter Lab, right, and it's running on my local computer, right? That's why it says it's running on the local host on this particular port, right? So if you introduce this address on your web browser, unless you have a Jupyter server running, right, which is you will need to download Anaconda, install Jupyter Lab, have Python, and so on, you wouldn't be able to see this URL, right? And that's the reason why I posted this on a service by Google called Google Colab, which is this link that Sandra and Amir shared, right? So if you go through this is the same notebook as I have here. Of course, I did add this image last minute, but everything will remain the same. And the other change is that since I'm using my local computer right now, right, this is a file I have on the same directory as the Jupyter notebook, and that's why here I put, let's just access the actual CSV file that I have in my directory, right? In the case of the Google Colab, right, you're pointing to this file from Dropbox. Okay, so if I go and copy this and run it here, right, I should be able to again be able to read this CSV file that it's in a Dropbox server, right, and read it, and then I'm going to store this CSV file as a data frame. And a data frame, for those of you who are not familiar, it's just it's how this pandas library store tabular data. Okay, so if I run this, right, if I run this, it should also work. Okay, so notice how this little dot here will be shaded because it's running, right? And as soon as it's over, it already imported it, right? So if I call this data frame, right, I can look at the data frame and I can run this cell by hitting Shift Enter or by hitting play here. Okay, and you'll see that I have all the data, all that CSV file as a data. Okay, so far so good. Let me see. I don't see the participants anymore. Here it is. Okay, yeah, I see a thumbs up from Sandra. Great. Brandon, thank you. Perfect. Great. Simming, awesome. Perfect. So thank you, Cyril, also that you're following along. Great. Okay, so this is a data frame, which is the first class citizen in the library's pandas, right? Which is a very popular library for data manipulation in Python. Okay, so the backend, if we look at which kernel we're using Python 3. Okay, so these are all Python 3 statements, right? If you use a different programming language, right, R or something else, you would have your own library for that. Okay, so there's a series of properties that relate to this data frame. So let me rerun it. I call it as a DF. yeah, here it is, right? So shape, for instance, right? Shape is a property of the data frame object that tells you the number of rows and the number of columns. Okay, so I can look, I can say, print, right? Num rows, and I can say df shape 0, right? And I can say print number of columns, and then look at shape 1, right? So right now we're just getting a feel for the data, right? We're just looking at in an exploratory fashion, what does the data look like, okay? So the other aspect, right, like that it's almost like the first statement that you would do. It's almost like looking at the head of the data frame, and the head of the data frame is just the first 5 rows in the data, right? It's a 0 index, right? So it starts from 0 to 4, right? Or I can look at the tail, which looks at the last 5 rows in the data. Notice how the row index it's increasing. So if we look at the head, we start from the top bottom, starting 0 index, and then it would go all the way to 3086, right? And here it is, right? Because it's n-1 because it's 0 index. Okay, so this is one of the first things you do just to get a feel for the data. And then the other aspect that it's important, right? Going back to this business understanding, is that what you're interested in making a predictive model on is using all these predictors or attributes to predict whether a customer will churn or not, right? And then this is, in this case, it's a binary classification problem where the outcome is either they churn or not. And then each row represents an individual user, okay? So, user 1, right? It has first name, last name, ID, and so on. We have demographic data. We could have the address, the gender of the primary member of the account, whether they're a senior citizen or not, right? Whether they have a partner or not, whether they have dependents, what's the tenure, right? This case, we would need to look in the data dictionary, right? Which is just the metadata, which is data about this data, whether this is represented as months or years, right? For the sake of this exercise, it's probably month, right? But even then, it's not so important because what we would like to see is the relationship, right? How tenure relates to whether someone's going to churn or not, right? So an initial hypothesis, right, if you're an analyst of this telecom company would be, I think that people that have a longer tenure are less likely to churn because they just got used to being our customer, right? It's, changing, calling a new telecom company, it just might be seen as a hassle, okay? And, that's your initial hypothesis, and then you would go and look at the data and validate whether that holds or not, okay? So let me check if there are any questions. And again, feel free to unmute yourself and ask the questions as well if you're following behind, okay? But the next thing it's important, it's that if we look at the churn variable, right? Since we're building our model on historical data, all the data needs to be labeled, right? And by needs to be labeled, I mean that this column should be either a 1 or a 0. It cannot be blank, because if it's blank, it sort of feels like it's an existing customer that we don't know whether that customer is going to churn or not, okay? So with this statement, and again, this is the beauty of pandas, right? But how you access data, it's like you call this data frame, this object, right? And then you say, well, I want to look at all the information in the churn column, right? And then I can look at that. And then it would print this series, right, of values. I'm ignoring everything because I specifically only want the information about churn. And then you can do, some methods on top of this sub series, right? And you can say, well, let me look at the sum. So can someone tell me, what does this 830 represent? Feel free to unmute or just put it in the chat.
I can go. I think it means that 830 people. So the one is the churn, right? So it means that if one, it says yes.
Yes.
So 800 people have basically left the company.
Churn.
Services, or yeah.
Exactly. So since we're summing and we know the outcome can be either 1 or 0, and 1 representing churn, right? Because it's the feature or attribute that's labeled as churn, right? So the event would mean it churned, and the not event would mean it didn't happen, so it didn't churn. Okay. So if we were to add all the values on this column, we would basically sum up the number of individuals that churn, right? So it means that, it's 830 out of 3087, right? So if we do 830 over 3087, that means that almost 27% of the customers, based on this historical data, churn. Okay, so one thing that we need to be careful is that we're only interested in those values that those instances or rows where we have a value for this, right? And that's what we do here, right? So rather than summing, we want to know, and again, these are sort of like methods that as you acquire more and more practice, you'll know them, right? And if not, you'll probably have to Google, right? A lot of this, it's going Google, going to Stack Overflow. So even if you don't have, I don't have a great memory, right? So sometimes, when we're learning a programming language, we have to Google how is it that I look at whether a row it's a null or not, right? Someone said, well, there's a method called isNull, right? Does it have an underscore here, right? I don't know. I don't remember. Was it isNull? So in this case, it's just this, right? So basically, what this method is doing, it's just looking and saying, this is not null, right? And it's false because it's 1, right? So there's not an empty value here. The second one would be false because there's also a value here, and so on, right? So it seems that the head and the tail, it all has a value for churn. But what we're gonna do is look, right? This is the subset. Again, this is the subset of the data. So what we're gonna look is all the instances in the data frame where there's a value that is small, right? So basically, we pass this as our filtering method, and we look at that filtering method across all our entire data. If we do that, now we get that only those that were true are shown here, right? So now notice how these are 4 instances where the value for churn, it's empty, right? And it's represented by A and N, right? So it's sort of like there's no applicable value for this. It's empty. Okay. So what we're gonna do next, right? If we were to look at the shape of this subset data frame, right? We have 4 rows and 15 columns. Notice how the number of columns didn't change, right? Because we were not doing anything but just asking for which of these rows don't have a value for churn. Okay, So again, if we remove the shape, we get the data. If we look at the shape, we only get at the size of these data, okay, which is 4 times 15, right? 4 rows times 15 columns, okay? So what we're gonna do next is we're gonna use this other method to drop anything that has an empty value in churn, right? And we're gonna assign that frame into DF again. So we're reutilizing the DF frame to now replace it with this data frame that does not include null values. So if we look at the shape of this new data frame, we'll see that, let me run this, and if we look at the data frame, notice how it's 4 less than the original data, okay? Because we just removed these 4 instances of null values, okay? So the next thing that pandas, it's very powerful to do, is to create subset of data. So you can add different filtering methods to filter the data in a very meaningful way for you, right? So maybe you say, well, you know, I want to look at how many males that have a 2-year contract have churn, right? So now it becomes more like a reporting type descriptive analytics where you're looking at filtering the data in meaningful ways, right? So in order to do that, again, what you're going to be doing is creating these filters, right? So let me close this. That's covered now. So let me, let's do it little by little, right? So again, if I do, let's look at the data frame DF. Let's lock in on gender, okay? And then let's only get those instances where gender equals male, okay? So if we do this, again, we're gonna get, notice how since the first one is female and we're looking at male, then it would be false, false. This one's male, so it would be true. This one's male, true, then false, and so on, right? So then we just don't want whether it holds the condition or not. We want the data. We want to retrieve the data that has those values set as true, okay? So can someone tell me what does this data frame compute?
So only those data that are the genders are male.
Perfect. Yeah. And how would we know how many rows or instances of these we have? What can we use? What method did we just learn earlier?
The shape.
Yeah, so we would just run the shape, and we know that there's 1,551 males in our data set. Okay, if we were to change this to female, right? There's 0 because I misspelled female here, but now we have 1,532. Okay, perfect, great. So we can do the same thing, right? For looking at those individuals that have a 2-year contract, right? And looking at this frame. And then we have that there's 730 individuals with a 2-year contract. And then the third condition, it's we're just interested in looking at those customers that have churn. Okay, and we're gonna also look at the shape. Okay, and we have 830. Okay, so the question here is how many male customers with a 2-year contract have churn? Okay, so it means, okay, it's a 2-year contract, gender, it's male, and churn equals to 1. Basically, what we need to do is use all those individual conditions as a whole. So we use that with an AND, right? An ampersand, and we just use a parenthesis and put each condition inside a parenthesis, okay? So that means now we're saying, look at all the rows or instances where gender is male, contract is 2 year, and churn it's equals to 1. So we're looking at the intersection. So if we run this, right, we can again look at the shape property, and we know that there's 11 customers that are male that have a 2 year contract and that have churn. Okay, does this make sense?
Yes.
Good. So let's see how are we doing. Thumbs up if you're still following. Thumbs down if you're a little bit lost and okay, still see thumbs up. I don't see thumbs down. So that's a good sign. So far, so good. Okay, let's move on. So the next one would be, and again, you can come up with this question and say, I'm going to go ahead and try to look at the data, right? Let the data speak to you and give you the answer. So it's sort of like when you write a SQL query that you say, this is the information I want. You write a query, the database outputs the result of the query, and then you have that report, right? In a similar fashion, there's a business questions, there's a hypothesis that you want to test. You write the code to retrieve that, and then basically. So this one is what's the ratio of average of total charges for male senior citizens to that of female senior citizens? So at first you read that question, it's like, what is going on, right? There's so much stuff going on. And you're like, okay, I'm just gonna unpack this, right? And the ratio still, I know a ratio has 2 parts, right? Like the numerator, the denominator. So let's look at what it's the numerator. So again, ratio of something. Ratio, it's the idiom is ratio of something to something, okay? So in this case, we know it's the average of total charges for a male senior citizen. So we know one filtering condition, it's they have to be male. Another one, it's they have to be senior citizens. And then we're gonna look at the total charges column, and then we're gonna look at the average. A lot of stuff is going on, but if we unpack that is, again, 2 conditions, right? Gender equals to male, senior citizen equals to 1, which represents that customer is a senior citizen, okay? And that, right, that would yield a sub-data frame, right? And then there are 241 customers that are male and that are considered senior citizens, okay? So the next thing we have, it's this old data frame, but it says you're only looking at total charges. So I'm just gonna focus on one column, which is total charges. And then you have the series, right? You have the total charges for those individual male senior citizens, okay? And the next thing is to compute the average, right? Which is the mean. So we're just gonna do that, okay? So we just unpack this point, okay? And then 2, it's that of a female senior citizen. So everything is the same, we just change female, okay? So we're gonna compute that, and we're gonna change male for female, and then we have that. And again, we're not done because the question asks for the ratio of this to this, right? So the last thing we would do, let's call it, let's call this male average total sales, okay? And we're gonna store this value in this variable, okay? And I'm gonna copy this, and I'm going to use this as female average total sales, okay? And then the ratio would be this over this, okay? So now we have the ratio of total charges male senior citizens, it's 1.03. Okay, so the next question could be, and I told you, right? Like my intuition is that customers that have higher tenure will churn or not, right? So again, in this case, I'm just plotting one. It's a univariate analysis of looking at tenure and plotting a history. Okay, so I do that, and I see this sort of like seems like positively skewed distribution, but it seems it's capped at 70. So probably everything above 70, it was just stored at 70 in the data. Okay, so we already answered this in a different way, right? How many customers have churn? We look at churn and then we did sum, right? But there's another method that you can use in categorical variables, which is called value count. And what it will do is for each level of the categorical variable, it will look at the how many of those are, right? So 2253 people have not churned, 830 individuals have churned. Okay, all this part, it's called exploratory data analysis within the realm of machine learning. Okay, so now we're gonna get into the predictive modeling aspect. Okay, so again, for the predictive model, what we do is identify which is your outcome, and we oftentimes refer to this as our target variable, and which are our predictors. So you can think of it as which is my dependent variable, which are my independent variables. Okay, so if you have a regression line or like the equation of the line, right? You have that, y equals mx plus b, or y it's a function of x, right? The outputs it's a function of the inputs, and then we're just considering this as these are the inputs, and based on these inputs, right? What should the outcome be, and what's the likelihood of that outcome being? Okay. In other words, these are the inputs, right? And then based on those inputs, what should be the outcome? Okay. Here it's just a pre-processing that we're converting categorical variables into. This is something called one-hot encoding, right? If you look at in the original frame, right, we had internet service. Let me rerun this, right? If we look at the head of the data frame, we're just gonna look at internet service, right? And then we're gonna look at the value counts. Again, since it's categorical, we are going to see all the different categories and how many of each of those categories are there. So certain algorithms work well with this kind of data, some of them do not. So oftentimes what you do is something called one-hot encoding, which basically says, okay, rather than having one attribute called the internet service, I'm gonna have n-1 attributes, right? So in this case, it would have, is it fiber optic, right? So is it internet service fiber optic? And is it internet service no? Or is it internet service DSL? Notice how we don't have internet service DSL because I'm dropping one of the reference values, right? The reason why I do this is to avoid something called multicollinearity, right? When we have like a high relationship between different attributes. And it's in the intuition here, it's like we know that if something is not fiber optic or it's not DSL, then it's the other only possible category it's not. So only knowing two of these, we know the third one, right? Because if it's no, then we know it's not DSL and it's not fiber optic. Okay, so the bottom line is we need n-1 categories to represent all the information. Okay, so that's what I did here. Gender male female was broken into one attribute, which is gender male. Notice how we got rid of gender female, because if we know the row it's not a male, then it is a female. Okay, so if we do this, we're just specifying that the input variables, right, or independent variables are this, and my dependent variable is that. Okay, here we're just specifying that the variable churn, it's binary, right? It's a categorical rather than int. Okay, and then the next step, this is very important because it's already modeling. So this is the key thing on supervised learning models, right? And the key thing here is that, think about it this way, and I'd like to explain it this way. Let's say I want to test you on everything we've seen so far, right? And then I'm going to create a study guide that you are going to be able to look at and learn from, okay? What happens if I share all the 10 questions there exist that I could ask and shuffle and think of, and I give them in the study guide? And then I'm like, well, there's no more questions that I can ask, so I'm just going to recycle some of the questions from the study guide. The problem with that is that, you know, when you come and do the test, I won't know if you knew the answer because you learned the answer from the study guide, or because you learned the concepts behind the problems in the study guide, and then you apply them to these new problems that I give you in the text, right? And this is the idea of why we typically split when we're building a model, because I would say, well, if I can only ask 10 questions, I'm not gonna give them up all, right? I'm just gonna give you 7 random questions, and I'm gonna hold off on 3 questions. You're gonna study from the 7 questions, and then I'm gonna test you on these 3 questions that I pulled out from the original study, okay? So when you come and perform the test, then I will know if you understood the underlying patterns in the questions in the study guide and the concepts. And, you know, we are discarding the possibility that you learned the answer because these are unseen questions to you. I know the answer to them. You know the answer to them, but you're just holding out because you want to test yourself before the actual test, right? Again, those 7 questions and those 3 questions, you already know the answer because it's part of the study guide. It's just a strategy that you're using to really know whether you're going to be prepared for the test, right? By randomly assigning 3, holding out to those 3. You know the answer, but you're not going to look at the answer. You're going to study from those 7 questions, and then you're going to apply the concepts learned to those 3 questions. And then you're going to see, right, whether you got the answer right or not. You're going to compare the answer of the study guide to your predicted answer, okay? It's a very similar relationship between splitting the model, okay? Again, this is all historical data. You know what the outcome was, but you're gonna hold off on 30% of that data, and you're gonna test your model on those 30% of the data, okay? Thumbs up if you follow this, if you understood this, because it's super important before we continue. Okay, wonderful, perfect. Okay, so that's exactly what we're gonna do. We're going to build a predictive model, right? In this case, we're gonna use a machine learning library called scikit-learn, right? Which is open source, right? And then, so we have to call, right? And say, these import statements are very important. I tend to put them with the problem statement, but once you have it all, typically what you do is you put them all at the beginning, all the inputs, right? So all the things that you're gonna be using, right? You're gonna put them here as the header, and you know, so on and so on. Okay, so what we're gonna do then is from this particular library, I'm gonna use this function, right, or class called decision tree classifier. And what the decision tree classifier executes a decision tree. We're gonna see what the decision tree is, right?
Quick question.
Yeah,
Just for students who are still new to this, can you maybe clarify why you chose the decision tree and not some other model, for example?
Yeah, so that's a good question. There's no particular reason why I chose a decision tree. I just think it's one of those models that are easier to understand. But yeah, typically what you do, right? If we go back to the Christian model framework, right? You will build multiple models. Like since this is a classification problem, you could do, a decision tree, a naive-Bayes model, a logistic regression, a deep neural network, right? Using TensorFlow, using H2O.ai, right? Or whichever open source library you want to use. But the overall idea is that once you have all those different models, then you're going to evaluate which model is the best in predicting the outcome. Okay? So in other words, like let's say I have an SAT test, right? The SAT is comprised of, math problems and then verbal problems, right? Like imagine we're gonna crowdsource as a group. We're going to do the test, right? So in this, we are 29 participants in total right now. So rather than, we're gonna go one question by one question in the SAT, and then we're gonna say, I'm on the math section, right? This is the problem. What is the answer? What do you think it's the answer? Okay, so then I'm gonna have 29 answers, and then somehow I need to, let's say it's a democratic vote, right? I would say whichever answer has the most votes, this is the one we're gonna choose as the final. So we're sort of like crowdsourcing the answer to the test. But what the model does, right? I'm the teacher, right? Let's say it's 28 students, one teacher. As a teacher, since I've been evaluating you throughout the semester, I know you as individuals, and I know certain individuals are very good at math, right? And some of them are English majors and so on. So very good at language, right? So rather than accounting as everyone as the same, I'll say, well, if this is a math question, I will put a little bit more weight to those answers coming from the math majors. And this is Jeopardy, right? If you have a call and it's a math problem, who you're gonna call, right? Someone that has math major or something. It's a verbal question. Who are you gonna call, right? Someone. So this is the same thing, and this is what the model learns, right? The model learns that which combination of attributes makes someone very likely to churn. Okay, so think about the model as the role of the teacher. If I'm a good teacher, I know your individual strengths and weaknesses, so I'm gonna be orchestrating depending on the question. I'm gonna be calling a math major, an English major, someone that has a physics major, and so on, right? So the best teacher would be the one that chooses which student should have a higher weight in answering the question. So in a similar vein, right, best model, it's the model that it's able to learn the patterns from the historical data and best predicts what the outcome is going to be. Does that answer?
Yeah, totally. Thank you so much.
Great. In this case, we're gonna see, we're actually just running a decision tree, but we and as an additional exercise, we could actually run a logistic regression or a different model. And then, so basically, without getting into the details, because this is something that you would learn in a machine learning course, right, or a data mining course. And the idea of the decision tree, it's that the uppermost variable in the tree, it's the most important variable in predicting the outcome. In this case, based on this decision tree, the uppermost variable in the tree is tenure, right? So then the nice thing about trees is that these nodes can become rules, right? So in this case, it says if tenure is less than or equal to 17.5, right? There are 1,500 individuals that have not churned, right? And there are 588 individuals that have churned. Okay, so that's the first condition. The second condition is if the internet service is, or if the user does not have fiber optic, meaning fiber optic equals to 0. And on the other hand, it's if the internet service it's also less than or equal, let me see, internet service fiber optic. Okay, tenure less than this and fiber optic 0, right? It'll keep going the branch. If tenure is greater than 17.5 and they don't have fiber optic, we still keep traversing this tree, right? Reason why it only has 4 levels, it's because, and I did jump ahead, right? But we need to build the decision tree. Let me back, right? How we build the decision tree, right, is we fit our training data. Let me see if I can draw here. Okay, let me annotate. And I'm going to spend a little bit more time, but I think it'll make it clear. Okay? Okay, so this are all your predictors. And then this, it's the outcome, okay, or whether they churn or not. Okay, nothing new. This is the data set that we were looking at. Okay. Let me bring this up here. Okay, it's stated, right? So this, it's just representing my combination of predictors and outcome, right? So the green ones are my predictors or independent variables, so all these columns, and then I only have one column for the outcome. So this is only one column as to whether they churn or not. Okay, so the next thing, right? Again, think about this whole thing as the original study guide, okay? So I said, well, it doesn't make sense to study from the study guide because then how are we gonna know if we, on the pretest, we did well because we learned the concepts behind it or because we learned the answer? So that this is why we're going to split the data and we're gonna leave 70% for training purposes and then 30% for testing purposes, okay? So I'm gonna study only using 70% of the data and then I'm gonna apply that knowledge and I'm going to make my prediction, okay? I predict this to be 1, okay? The first problem set on my testing data, I predicted it to be 1. And if it was 1, then good for you, you got it right, okay? I'm gonna predict this to be 0. If it was 1, then you made a mistake here, and so on, right? For those 30%. And then how good you did is how many misses, hits or misses you have across the data, right? Does this make sense? It's a little bit confusing, but that's exactly what we're doing on this particular statement, okay? We say, now we're gonna split the data. This would be your validation set or testing set, and this would be your training set. Notice how there are 4 quadrants here. There's one quadrant here, another quadrant here, another quadrant here, and another quadrant here. Okay, so these are the how they're represented. We have train X, which is the inputs on the training data. We have train Y, which is the inputs on the validation data. We have, sorry, train Y would be this, right? Let me undo, right? This is train X. This is train Y. Sorry about that. And then this is valid X. And this is valid Y. Okay? This is what we're doing with this train test split. Because we're saying use 70% of the data to train and use 30% of the data to test. Okay? So let me see by show of hands if you understood this part. Thumbs up if you're following, still following. Okay, wonderful, great. Thanks for the feedback. Let me keep going then. Let me erase this. We're almost done, we're almost done. And then I'm gonna open it to questions, right? So what we're doing here, we're saying, okay, this model that I built, I'm gonna fit my data and see how well I did, right? So I'm gonna look at, I'm gonna use the train X and train Y. I'm gonna use my training data and I'm gonna see how good I did with and I'm gonna use my Y to learn the patterns, okay? And then we built this model and this is the model we built. And then the next thing we're gonna do is we're gonna look at how well we did, right? And there's two metrics that we could use, precision score and recall score. Precision, it's the number of true positives, right? And recall. And I don't want to get too much in the weeds here, but I just want to show you that in my data, I have churn, right? Which is what the actual value is. And then I have something different, which is churn my prediction, okay? So if the actual value was 1 and my prediction was 1, this is something called true positives, right? Because I got it right. I predicted it to be positive and it was true. But if the churn was actually 1 and I predicted it to be 0, then this would be I predicted it to be 0, not 1, but that was false because it was 1, right? So that's false negative. The next one would be I predicted something to be 0. Sorry, the actual was 0 and I predicted that something to be 1, then again, I predicted something to be positive, but it was false because it was negative or 0, okay? And then the last one would be something that it's 0, I predicted it to be 0. So I predicted it to be not 1, and that was true, okay? So if you have all the actual values in your predictions, then you're gonna start adding this up, and then based on this, using this formula, you're gonna calculate the precision and recall. Notice how if you have, so can someone tell me here, right? We have true positives, false negative, false positives, true negative. Which ones are mistakes and which ones are correct? If someone can unmute themselves and tell me which one of these represent a correct and which ones correspond as a mistake.
So for correct, true positive and true negative.
Yes, exactly. And mistakes would be
The other two.
false negatives and false positives, right?
Yeah.
Something was something, and I predicted it to be that something, right? And something was something, and I predicted it to be something else, right? These two. Why is this important? Because, think about this formally, right? What do you think, the value of precision should be in the best model you can get, and why? Should the precision be closer to 1 or closer to 0? Again, remember, these are correct ones and these are mistakes, right? So what would be the best outcome? The best outcome would be one that minimizes the mistakes, right? So let's assume the best model would be one that makes no mistakes. What would be the precision?
Wouldn't it be true positives over true positives, so 1?
Yes, exactly, right? So
Okay.
the precision would be 100%, okay? We're precise 100% of the time. What would be the best outcome for recall? Again, not making mistakes, right? And again, we said a false negative, it's a mistake. So if this is 0, then we would have true positives over true positives. Then the best model would yield a recall of 100% as well, right? So in the real world, of course, this never happens, right? So we have to achieve this trade-off, right? Between having higher precision and higher recall. So if we look at the precision score of our predictions, we see that we have a precision of 60% and then a recall score of 59%, right? What are the most important variables? Well, we can sort by feature importances, right? And we can see that tenure, it's the most important one, then second one, internet service fiber optic, then charges, which makes sense. It was one of the original assumptions, right? People with the higher tenure are less likely to leave, and maybe people that are being charged a lot are probably going to look for something cheaper, right? A different option, okay? So in a nutshell, we just went through the entire process of machine learning, choosing first what the business question is, what data we have at hand, making some data preparation, and building a predictive model, evaluate that model, and then if we're happy with this model, then we can deploy. Okay? Any questions so far? So I'm just gonna stop now. We went through the entire notebook. This was just a different aspect of exploratory data analysis where we can draw box plots across the contract type and then look at the monthly charges, right? So this could be one hypothesis, right? People that pay month to month will typically be in worse plans than people that have longer term contracts, right? So if you look at the range of monthly charges for month to month, right? Like if you look at 2-year contracts, there are 2-year contracts that start at almost $20, and the mean monthly charge for 2-year contracts, it's the median, it's typically lower than on month-to-month contracts. Okay, so these are just relationships on the data you can look at. Okay, this was sort of like a full cycle. Again, if you're looking at the data mining course or an analytics course, there's courses that fully focus on data visualization. There's courses that fully focus on data modeling and predictive modeling. There's some other courses that may focus on like feature engineering and so on, right? So I just wanted you to see the whole picture, and then each of these components in the process, it's a full universe on its own, right? But at least if you have the full picture of how machine learning works and how specifically supervised learning, again, supervised because we have something, we have a dependent variable we're trying to predict on, then, you know, it's useful and you can apply some of these concepts to a different context, right? You know, churn, predicting default of who's going to default alone, predicting us who's going to be readmitted to the hospital based on their health records and so on. So I'm going to stop here. I'm going to open the floor for questions and comments and you know, see if this was useful and what other topics you would be interested in. So let's make it an open discussion. Feel free to unmute yourself, see where your journey is at, what do you plan to do next, and so on, or have any questions in general or on careers and data. Open to any questions. So thank you.
Okay, let me just stop recording and